Hello students, welcome to LearnGuru Classes. So today is a continuation of the last class where we will be solving some sums related to laws of exponents. So let's begin our class. So the first sum is you have to simplify this particular expression. Okay, now next duty is you have to find 81, 16, 25 by 19, 5 by 2. 5 by 2 is already a prime number. 5 is also a prime number. 2 is also a prime number. So our duty is to find out to express 81, 16, 25, 9 in terms of powers or exponents. So the next step will be, I am writing the expression as it is and I am giving here equal to. So 81. So 81, see here one more trick. 81 is 9 square is also equal to 81 and 3 to the power of 4 is equal to 81. Now you have to judge which one will work for you. Here 9 square will not work. Yes, it will work, but what will happen? The steps will increase. Okay, so if I go for 3 to the power of 4, so if you see here 81 by 16 whole to the power of minus 3 by 4 is given. So this 4 and 3 to the power 4 can get cancelled. How we will see in the next step. Okay, so and 16 you can write 4 square is equal to 16 and 2 to the power of 4 is also equal to 16. Now obviously 2 to the power of 4 will work for this particular sum. So what will you do? So this one is 3 to the power of 4 and this is 2 to the power of 4. So this is to the power of minus 3 by 4 into you have 25. So 25 is 5 square, isn't it? So this is 5 square and this is 3 square to the power of minus 3 by 2 divided by 5 by 2 to the power of minus 3. Now 5 is also a prime number, 2 is also a prime number. So at least you can write 5 to the power of 1. So there is no use of writing, isn't it? So I will close the bracket. I hope up to this you have understood. Okay. Now next step is if suppose a to the power of m by b to the power of m, any expression is given to you where you have two different bases but the power is same. So what you do, you take the power as common, that is a by b to the power of m. Okay, so same thing you are going to do over here. 3 by 2 to the power of 4, give a bracket into minus 3 by 4. Okay? Yes, I can write this one into this will become as 5 by 3 whole square into minus 3 by 2. Yes, I can write, and divided by 5 by 2 to the power of minus 3. Okay, now this 4 and this 4 we can cancel. Yes, this 4 and this 4 we can cancel. So you are getting 3 by 2 to the power of minus 3 into this you are getting as 5 divided by 3, 2 will get cancelled. So you are getting 5 by 3 to the power of minus 3 divided by 5 by 2 to the power of minus 3. Okay, up to this everybody has understood. Now you see what to do next. Next is, you know by the rule that a to the power of minus 1, if it is given, we can write as 1 by a. Similarly, a to the power of minus n, if we can write it as 1 by a to the power of n. So here what I will do, here 3 by 2 to the power, so 3 I can write as 1 by 3 to the power of 1 by 3 to the power of 3 by 1 by 2 to the power of 3. Yes, I can write in this way. Into this also I can write it as 1 by 5 to the power of 3 divided by 1 by 3 to the power of 3. Okay, divided by this also we can write as 1 by 5 to the power of 3 divided by 1 by 2 to the power of 3. Okay, written. Once it's written, so what we will do? We will just, this is 1 by 3 to the power of 3 divided by 1 by 2 to the power of 3. So this will go 2 to the power of 3 divided by 3 to the power of 3. Okay, into you can write it as 3 to the power of 3 divided by 5 to the power of 3. Divided by, you can write it as 2 to the power of 3 divided by 5 to the power of 3. As simple as that. Okay. So 1 by 5 to the power of 3 divided by 1 by 3 to the power of 3. So 3 to the power of 3 will be above of this. So this will become as 2 to the power of 3 by 3 to the power of 3. Okay. And into 3 to the power of 3 by 5 to the power of 3 into 5 to the power of 3 divided by 2 to the power of 3. So 2 to the power of 3, 2 to the power of 3 you can cancel. This also you can cancel. This you can cancel. So ultimately the answer is 1. Okay. I hope you have understood this concept. That is 1 by A by 1 by B. So you can write it as 1 by A, that is B by A, isn't it? B by A. So similarly here also 1 by 3 to the power of 3 divided by 1 by 2 to the power of 3, that is 2 to the power of 3 divided by 3 to the power of 3. Okay, I think this concept you have already done in your lower classes, so this won't be a problem for you. And the rest of the thing, following the laws of exponents, you can easily solve it. Okay, so let's move on to the next sum. This is the second sum where you have to prove 2 to the power of x minus 1 plus 2 to the power of x divided by 2 to the power of x plus 1 minus 2 to the power of x equal to 3 by 2. Now how to proceed with the sum? So first hint, that is you have to prove that it is equal to 3 by 2. So the main target for you will be to get rid of this exponent, that is 2 to the power of x. So x is the power, isn't it? And this will be in the form of a fraction where it is free of any power. Okay, so this is the first aim that you have to fulfill. Now we know again another law that we are going to use over here is that a to the power of m into a to the power of n equal to a to the power of m plus n, isn't it? Where same base is there but powers are different, and if it is multiplied, product of this gives a to the power of m plus n. Okay, so the same thing we are going to do over here. So here let's write LHS equal to 2 to the power of x minus 1 plus 2 to the power of x divided by 2 to the power of x plus 1 minus 2 to the power of x. Okay, so along with this formula, another formula that will be used, a to the power of m by a to the power of n equal to a to the power of m minus n. Now come to this first term. Okay, so is it of the form of a to the power of m minus n? Where a to the power of m we can write it as 2 to the power of x, and a to the power of n we can write it as 2 to the power of 1. So a to the power of m minus n you can write as 2 to the power of x, a to the power of x minus 1. Yes. So if a to the power of m minus 1 is equal to 2 to the power of x minus 1, so this can be easily written as 2x by 2. Yes. Yes, according to this formula I can write. Yes or no? So here what I will do, I will just write as 2 to the power of x by 2 plus 2 to the power of x. I can simply write. Okay, now come to this particular expression, 2 to the power of x plus 1. So is it resembling a to the power of m plus n? Is the term resembling this term a to the power of m plus n? Yes, if I write a to the power of m equal to 2 to the power of x and a to the power of n is equal to 2, that is a to the power of m plus n, we can easily write as 2 to the power of x plus 1. Okay, so if a to the power of m plus n is equal to 2 to the power of x plus 1, so m into a to the power of n, that is a to the power of m plus n, that is we can write 2 to the power of x into 2. Yes, I can write 2 to the power of x plus 1, we can write it as 2 to the power of x into 2. So here also we will write 2 to the power of x into 2. So in place of 2 to the power of x plus 1, I can write 2 to the power of x into 2 minus 2 to the power of x. Okay, now the next is you have to get rid of this power, isn't it? 2 to the power of x, because on the right hand side you have a fraction which is free of any powers. Okay, so what I will do, I will from here I can say that 2 to the power of x is common to both these terms. So I can write 2 to the power of x. So this is 1 by half. 2 to the power of x by 2 is 1 by half plus 1 I can write, and this is 2 to the power of x, that is 2 minus 1. Up to this I can easily write. Okay, now what I will do, 2 to the power of x, this is half plus 1. So this is 2, I can easily take the LCM, and this is 2. So this is 2x, 2 minus 1 is 1. So 2 to the power of x, 2 to the power of x, I can easily cancel it out, and 1 plus 2, 3 by 2 divided by 1, that is 3 by 2 is the answer. So this is right hand side, equal to right hand side. So this is hence proved. Okay, you must know how to use these rules. Okay, so by looking at the expression, suppose this expression, it should strike your mind that which formula I can use. Okay, so this is the key point or key rule of solving this type of sums. Okay, so let's move on to the third set of sum. The third sum is also you have to prove this expression is equal to 7 by 10. So similarly, the procedures that you have followed in the last sum, so that only you have to use over here. Okay, so LHS, I will write LHS equal to 2 to the power of 30 plus 2 to the power of 29 plus 2 to the power of 28, 2 to the power of 31 plus 2 to the power of 30 minus 2 to the power of 29. Okay, so here also you have to get rid of the powers. Okay, so over here, first let me show you how it is done. After that, I will tell you what is the reason behind I have chosen this. Okay, so first of all, in this numerator, which has the lowest power over here? 30, 29, 28. So 2 to the power of 28, it has the lowest power, isn't it? Here 2 to the power of 29, in the denominator 2 to the power of 29 has the lowest power. Okay. Now here you are to use this formula, a to the power of m into a to the power of n equal to a to the power of m plus n. Okay. Now if I take 2 to the power of, suppose 2 to the power of 30. So this we can write, can I write this as 2 to the power of, if 28 2 to the power 28 I have taken, so chosen it is the lowest power. So suppose 2 to the power of 28 plus 2, I can write 2 to the power of 30, I can write it as 2 to the power of 28 plus 2. So this can be, according to this formula, I can write it as 2 to the power of 28 into 2 square. Yes, up to this it is clear to you. Okay, now 2 to the power of 29. 2 to the power of 29 can be written as 2 to the power of 28 plus 1. So this can be written as 2 to the power of 28 into 2. So let's put all these values over here. So this will be 2 to the power of 30. We can write it as 2 to the power of 28, 2 square, plus 2 to the power of 29. We can write into 2 plus 2 to the power of 28. Now here, if it is 2 to the power of 29, I have chosen as the lowest power. Okay, so 2 to the power of 29. So let's see 2 to the power of 31. So I can write 2 to the power of 29 plus 2. So that is 2 to the power of 29 into 2 square. Okay. Here you can write 2 to the power of 30. You can write it as 2 to the power of 29 plus 1. That is 2 to the power of 29 into 2. And 2 to the power of 29 is left as it is. So I will take 2 to the power of 29 into 2 square plus you will have 2 to the power of 30. 2 to the power of 30 you can write it as 2 to the power of 29 into 2 minus 2 to the power of 29. Okay, up to this it is clear to you. Now here in all the terms you have 2 to the power of 28. So let's take 2 to the power of 28 as common. So this will be 2 square plus 2 plus 1. Okay, and this you can write it as 2 to the power of 29, 2 square plus 2 minus 1. Okay, now let's keep 2 to the power of 28 as it is. This is 2 square is 4 plus 2 plus 1. And 2 to the power of 29 we will write as it is 4 plus 2 minus 1. So this is 2 to the power of 28. So the 4 plus 2 plus 7 into 4 plus 2 plus 1 is equal to 7, and 2 to the power of 29 into 5. Okay. Now 7 by 5 is let us leave as it is. 2 to the power of 28 by 2 to the power of 29. So both of them has the same base. So what formula will you apply for this? You can write a to the power of m by a to the power of n equal to a to the power of m minus n. So here 2 to the power of 28 by 2 to the power of 29, that is I can write 2 to the power of 28 minus 29. So that is 2 to the power of minus 1. So this can be written as 1 by 2. So I am not showing here because of the space constraint. So 2 to the power of 28 by 2 to the power of 29, we can write it as half. So 7 divided by 2 into 5, that is you are getting as 7 by 10. So this is equal to RHS. Hence proved. Hence proved. Okay, so this is how we solve this type of sums. We will solve many more sums related to laws of exponents in the next class. Okay, so here I am ending the class. If you find this video helpful, please subscribe to LearnGuru Classes, like, comment and share it with your friends and relatives. So thank you so much. Bye-bye.